Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through the journey of non-homogeneous differential equations. And as you might guess, a first order non-homogeneous linear differential equation um, has the form, the first derivative, which is y prime plus p of t multiplied by y equal to some function of t. Okay. All right. Um, Not only is this closely related in a form to the first order homogeneous linear equation, we can use what we know about solving homogeneous equations to solve the general linear equations. Okay. Now I want to also kind of point out that when the coefficient of the first order of the first derivative is 1 in the first order non-homogeneous linear differential equation as in the above definition, then we can say that, or in the above form, then we can probably say that this is in the standard form. Okay, does that make sense? All right. Now, there are various methods of solving non-homogeneous differential equations. The first one, we call it the integrating factor. Okay, so we can use the method of integrating factor. So we say method of integrating factor. Okay, we can use what we call variations of parameters. Okay, variation of parameters. Okay. Now, these are some of the techniques that we use to solve such kind of problems. Okay, but then for a start, we want to start with the integrating factor. Okay, good, good. Let's get going. And at this point, if you have not subscribed, please do so. Comment, like, and share this content with your close loved ones so that we can help demystify the myth around mathematics. All right, so let's get going now. Um, it is important that I kind of talk a bit about the integrating factor. So integrating, let me write it here. I'm not going to prove it, but then we are just going to use it as a method to solve the problem. Okay, in this particular instance. So we want to say that this integrating factor, which is p of t, which is I of t, is equal to e to the power the integral of. Now, what are we going to pick? We are going to pick this, the coefficient of y, which is pt. Okay, p dt. Very good. So this is an integrating factor. So anytime we find non-homogeneous differential equation of this nature, then one of the easiest method techniques is what we call the integrating factor, and that is how we kind of use that. Okay. Now, what basically we do with this integrating factor, what we do with that is that we use it to multiply both sides by the result that we get. Okay, and then we integrate both sides. Okay, so so what we're going to do at this moment, we're going to pick an example so that you will know how best we kind of use this method. Okay, so let's get going. So let's look at the first example. So the first example, so example 1. So the example 1 says solve the solve the differential equation, which is dt plus 3t squared y equal to 6t squared. Now, how do we solve this problem? How do we solve this problem? Now, we kind of said that such a problem, when we such a problem, okay, let me write it down. Now, when we relate this problem to the standard form, we said that the standard form, is a standard form, okay? To the standard form, we said that by deploying the integrating factor, okay, the integrating factor, we said that the integrating factor is going to be e to the power the integral of p of t, okay, and the p of t dt. Now, if we should look at the given problem, the p of t is this particular term, which is 3 t squared, okay? So we're going to have the integral of 3t squared dt. Now, what is the integral of this? So the integral of this will give us what? A to the power. So with this one, we increase the power by 1. We increase the power of t by 1, then divided by the increased power. So in that case, we're going to have what? Um, t to the power 3. Okay, so this is going to be our integrating factor. But how do we use this integrating factor to solve the problem? Now, what we are going to do is that we are going to multiply both sides of the differential equation by such integrating factor. Okay, then we kind of continue from there. Now we are going to multiply both sides of the of this differential equation. Okay, by the integrating factor. So the integrating factor is this one. So we're going to have e to the power t to the power 3 multiplying dy dt plus 3t squared y equal to e to the power t to the power 3. Then the other side we have 6t what t squared. I hope that makes sense. All right. Now, what happened is that now over here, there's a trick that I always tell my student to use, and it's very simple. So what happened is that we're going to have our d dx, it's in terms of t, so it's d dt of, now what is the integrating factor? Or the integrating factor is what? A to the power. Now this particular term on the left, which I just underlined, can further be simplified in a way that can be written in a way that when we differentiate it with respect to time, it will get the same result. Okay. So what I usually tell my student, what I tell them is that just look at the integrating factor. And the integrating factor in this case is e to the power t to the power 3. Then what is the dependent variable? The dependent variable is what? Is y. Now, if you think I'm wrong, just try and differentiate this if you will not get this result. Try and differentiate if you will not get this result. If you don't get it, just contact me in the chat box and I'll read back to you. Then we'll talk more about it. If you don't get it, then I can give you some $1 to check something. So let's get going. Now let's simplify this. Now when you simplify this, we get what? We get the same thing. Okay, but in this form, in its simpler form. Okay. Now this is the result that we have. Okay. Now to solve this, to solve this, we can just say, let's kind of, you see that we can just do separable. Okay, this is so it's separable in its simpler form, but that we can rewrite this as this, a little bit of algebra. Okay, let's write it this form dt. Then we take the integral on both sides. Is that okay? Does that make sense? Now, anytime I take the integral of the differential of something, I always get what is, So let me bring you let me draw your mind to something. So for instance, if I have the integral, let's do some one or two things here. So for instance, if I give you the integral of the x, I'll always get x here. Okay? Does that make sense? If I give you the integral of d of anything, I'll always get what is here, what is inside the bracket. Does that make sense? So that's the same thing here. Okay? Suppose I give you the integral of d of ax. I'll always get ax. Okay? So now the integral of d of e to the power t t to the power sorry, the integral of d e to the power t to the power 3 multiplying y will give you what? A to the power, sorry, let me get rid of this one. We'll get you e to the power 2 to the power 3 multiplying y. Okay. Then on the right hand side, now this is if you if you have been following us in our previous episodes, we kind of learned integration by substitution, right? So on this side, if you use integration by substitution, you should be able to get a result. And by using integration by substitution, you should be able to get um, 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 2 multiplying e to the power t to the power 3. Okay. Then we add some constant c. And the reason we add a constant c is because this is an indefinite integral. Okay. Okay, good, good. So let's get going. Now we need y and not just a to something multiplying y. Okay. So why do we need to divide both sides by y? And by dividing both sides by y, this implies that y should be equal to be 2 plus what? Plus some constant. So c multiplying what? Minus t this. Okay. Does that make sense? So this is just a general solution, not a particular solution, okay? Because we have not been able our problem was not subjected to a particular condition. Does that make sense? All right. So it means that the solution to this problem is this particular one. Now let's look at another example. So example 2. So with example 2, it says that we want to find the solution of the IVP, that is initial value problem, t squared y prime plus ty equal to 1, where t is kind of positive, okay? But then this time around, we want to subject a solution under this particular condition, okay? I hope that makes sense. Now, given this particular problem, so we want to use, you want to use the integrating factor. So what do you think the integrating factor will be? So integrating factor will be e to the power the integral of what? Our p in this problem is what? Is what? Okay, so the easiest way, you see, look at this one. This one does not look directly. So let me do do a recap here so that everybody will get it. I know somebody will say that p of t will just be t, but that is not true. I'm going to explain that in a bit. So this, this particular one does not look just like this one. You see, it does not look like this. It does not look like the standard form. It's because the coefficient of the y prime is not 1. Because it's not 1, it means that we have to divide through by t squared for that to happen. Okay. So if I were you from here, what I would do is that I would divide both sides by t squared, and that will give us something. If I'm dividing both sides by t squared, it means that I'm going to have 1 over t here, y, okay, then equal to 1 over what? T squared. But we said that t should never be 0, right? So now we can now go straight to find the integrating factor, okay, from here. Now it means that our p of t would just be this particular term, okay? Does that make sense? So it means that we're going to have 1 over x dx. Does that make sense? And then this, what is the integral of 1 over x? We said is what? The natural log of x, right? So we're going to have e to the power then x. And that is the same as what? X. The reason is because the exponential function and then the natural log are inverse of each other. Okay, good. So that's the explanation for that. Now, for me to go forward to solve the question, remember we said that once we have access to the integrating factor, we have to use that and multiply both sides of the differential equations by that. Okay, good. So on that note, we're going to have x multiplying the differential equation that we have, which is y prime plus 1 over t y equal to 1 over t squared. Sorry. And then this also multiplying what? Well, I'm using t and it's supposed to be t and not x. So let's take note of that. This is t. This has to be t, and this also has to be t. Good, good, good. So now when we said that with this one, the easiest way we want to simplify this is to what? Is to have your d dt of your integrating factor, which is t, then your dependent variable, which is y. Okay. I hope that makes sense, right? Now, at this point, what you want to do is that you can rewrite this as what? Y 1 on t dt. Okay, then we take the integral on both sides. And we said that this one is what? When we integrate this, you only have what is inside the bracket, right? So we're going to have ty equal to, and then what is the integral of this? So the integral of this is what? The natural log of t. So then you add some constant, let's say c. Now over here, we just need y and not ty, okay? So this implies that my y will just be the natural log of t on t plus some constant on t. Does that make sense? So that is the result, that is the general solution that we have. So this is our general solution. But remember that our solution, there was a restriction that we were given some initial condition. We said that we are y of, we claim that since y of 1 equal to 2, then we have that. So which means that wherever I see t, I should replace it by 1, okay? From here, then I should equate the result to what? To 2. But the question is, what is the natural log of 1, which is what? 0, right? So in that case, you're going to have c equal to what? 2. So this implies that your y of t is equal to what? The natural log of t on t plus 2 on 2 or on 2 on t as our final result. Okay? And this, you can simplify this as further as what? Ln of t plus 2 on t. Does that make sense? And at this point, if you have not subscribed to our channel, please do so. Like, comment, and share this content with your colleagues, with your loved ones, and let's help demystify the myth around mathematics. Stay blessed. Bye.